Hey folks, wanted to walk you through domain of a tangent function really quickly. I've drawn here multiple periods of my tangent parent. So you'll notice that this is the one that we drew for today. I also told you that I really like to look at, when I'm comparing to cotangent, I really like to look at it from 0 to pi. That's another period. So just that's what we looked at today. I didn't realize that domains were heavily on your quiz, which is why I wanted to give you this video. So the first thing is notice that for my domain here, I'm going to be using all real numbers. The real number symbol, remember, is that all real numbers. However, I have to throw out all of those times where I have a vertical asymptote, because you cannot throw a vertical asymptote into your domain. You're not allowed to equal that particular value. So I can't say that I'm going to have all real numbers except for pi over 2 and 3 pi over 2 and negative pi over 2 and negative 3 pi over 2, because this list is an infinite list. There's no way I can list them all. And so I have to come up with a way where I can do this a little bit easier. And so the first thing I'm going to say is that my domain, first, it is all real numbers, but we'll say if I'm working on set builder notation form, x such that x is not allowed to equal. Okay, so what is it not allowed to equal? Well, it's not allowed to equal pi over 2, 3 pi over 2, negative pi over 2. So let's just take the smallest of those values, the pi over 2. But then not only is it not allowed to equal pi over 2, it also cannot equal all of the other asymptotes. So think about how far away each of those asymptotes is. How far in between asymptotes is this? Well, that's your original period of pi. So if I take my pi over 2 and I add pi to it, that'll say that I also cannot equal this value. That makes sense, except that I still have a lot of values that I haven't included. So if I add another pi, that will work. And if I add another pi and another pi and another pi, that will work. So what I'm going to do here is I'm going to say I'm adding pi times n. Pi times n is showing me that n is an integer, n is a whole number. So it's whole pi's that I'm adding here. So I'm starting with pi over 2. And I'm adding whole pi's. And for the record, I could be adding a negative whole pi. So that n can also be a negative number. So that will help me then to get my negative values. Now, I wanted to take you to the cotangent question that we did at the end of class today. And if I were to draw a few more periods of this, I only had to draw one. But if I were to draw a few more periods, my domain on this one, we would say that x cannot equal 0 because I have an asymptote here on the y-axis, 0 plus, now think about how far away the next asymptote is. It's a distance of pi over 4 away because my period was pi over 4. So I'm going to say then it's 0 plus pi over 4 n. And remember that n can be negative, so that helps me to deal with both the positive and the negative asymptotes. Hopefully that's a help to you.